Hello, my dear students. I am going to start for class 12 relation as well as function also. So first time I will explain about the relation. Then after completing the relation I will start function also. So let's see what is called relation. See, A is a set like its elements 1, 2, 3, and B is another set like 0, 1 and 2 6. Now if we want to cross multiply, then A cross B will be equal to 1, 2, 3. Let us cross multiply it, then it will be 0, 1, 2. So in this between, if we want to multiply them in a Cartesian product, then it will be within first bracket 1, 0, next 1, 1, next 1, 2, next 2, 0, 2, 0, then next 2, 1, then 2, 2, then again 3, 0, 3, 1, and at last 3, 2. So this one we can write as 1 related with 0, 1 related with 1, then 1 related with 2, 2 related with 0, 2 related with 1, 2 related with 2, 3 related with 0, 3 related with 1, 3 related with 2. So, as an order pair or 1 related with 0, 1 related with 1, in this way we can write any relation. So, if A and B be any two sets, then if we want to multiply them A and B, then here 3 elements, here 3 elements, so 3 3 is 9, so there will be 9 order pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this can be written as 1 related with 0, 1 related with 1, 1 related with 2, 1 related with 0, 1 related with 1, 2 related with 2, 0 related with 0, 3 related with 0, 3 related with 1, 3 related with 2. So, in terms of order pair or as a relation also, we can express this one. Let us take one diagram. Through the diagram also the same thing we can show here. Say the elements of A we have given here 1, then 2, 3. As a ray diagram, we can show this relation as follows. That is, first one is 0, 1, 2. So how can give this relation? This one is B, say, then A is related to it, B. And the relation such that A to B. And the relation from A to B. And the relation from A to B. Then, if we want to say 1 is related with 0, 1 with 1, 1 with 2. Next, 2 with 0, 2 with 1, again 2 with 2 7. Then again 3 with 0, 3 with 1, then 3 with 2. So this is called a arrow diagram. Arrow diagram. So in this case, total number relation, how can find from this? How many possible relations can establish establish here. So 3 is 9. So total number relation will be 2 to the power modulus of a cross b. The total number of elements in the a cross b is 3 is 9. So it will be there 2 to the power 9. Now what is the numerical value of 2 to the power 9? It will be say 2 cube into 2 cube into 2 cube set. Then 2 cube 8, 2 cube 8, 3 plus 3 6, 6 plus 3 9. So 2 cube is 8, 2 cube is 8, 2 cube is 8. Then finally 8 is 64, again multiplied by 8. It will be 8 4 is 32 minus 3. Then 8 6 is 48. 48 plus 3 it will be 8, 9, 10, 11. So 512. So it will be then 512. So total number of relations will be here 512. So from A cross B we can establish 512 relations. So for any Cartesian product we can find the number of relations according to the order pair, number of order pair. So if the number of order pair is given suppose n in the set modulus of A equal to m set and modulus of B equal to n, then total number of elements in A cross B will be A cross modulus of A cross B. Then finally it will be 2 to the power mn. 2 to the power mn. So these will be the total number of relations. If modulus of A equal to m and modulus of B equal to n, then modulus of A cross B will be mn. So 2 to the power modulus of A cross B, that is 2 to the power mn, will be the total number of relations. So that can establish from this. If the order pair is A and B is m and n, then total number of relations will be 2 to the power mn. Then what will be A cross A? If we have given A equal to A, B, C, then A cross A will be how much? A cross A will be A, B, C multiplied by again A, B, C. Then let us multiply with this. It will be A, B, A, C. Then next B, A, B, A, B, B, C. Then C, A, C, B, plus C, C. So how many order pair will be here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 2 to the power 9 again. The total number of relations will be 512. So whenever in a set A there are given 3 elements, then it will be modulus of A will be 3. Then A cross A, in A cross A there will be total number of elements will be 3 here. So from here we can establish 512 relations. That will be 2 to the power 9. 2 to the power 9 is 512 relations. 512 relations. So all the relations may not be applicable for us, but according to the definition of the relation, we can establish the number of different types of relations. So all the possible subsets of A cross A, will be one special types of relations. So total number of relations will be here 512 relations. Then among them there is some special types of relations. So out of that, first one is identity relation. Say IA. I suffix A means identity relation. Now what is called identity relation? That is, A comma A comma B, B comma B, then C comma C. If X comma Y be any order pair, whenever X equal to Y, by taking all the like order pair A, B, B, C, C, and beside that there is no any other elements, so it should be for all A comma B comma C belongs to the set A. For all A, B, C belongs to A. That is why this identity relation means same order pair. First component and second component must be same. Then it will be identity. Besides that, there cannot exist any other order pair except the like, that is A, B, B, C, C. So that is called identity relation. Now what is called reflexive relation? Identity relation. I suffix A. So identity relation can represent by I suffix A. I suffix A equal to A, B, B, C, C. So that is called identity relation. Now next, say what is called reflexive relation? Reflexive relation. Reflexive relation. So it will be say R is a reflexive relation. It should be like this. A comma B comma C comma C. Besides that, there can exist any other order pair also, say A comma B, or one or more than one also there can exist. So besides the like pattern, there may be a like pattern also, order pair, then it will be a reflexive relation. Here, for all A comma A, means that means for all, say if X belongs to A, then for all X belongs to X comma X must be relation which supposed to be belong to R. For all X belongs to A, if X comma X be a relation, then it will be a reflexive relation. Besides that, there may be any other order pair also. So this type of relation we can say as a reflexive relation. The next, symmetric relation. What is called symmetric relation? Symmetric relation. If a another relation like A comma B, B comma A B, B A, then B C and C comma B also present here. So that is called symmetric relation. A comma B implies B comma A. If A comma B is a relation, then in that relation there should exist B comma A also. So for any order pair, its inverse order pair also supposed to present here, then we can say it is a symmetric relation. So it is not necessary that for all the order pair elements, let's say A, B, B, C, C, for all may not be satisfied. But whatever is any order pair is given, its inverse order pair also supposed to present here unless it cannot be symmetric. Next, anti-symmetric relation. What is called anti-symmetric relation? Anti-symmetric. Anti-symmetric relation. What is called anti-symmetric relation? If a relation is not symmetric, then definitely it will be an anti-symmetric relation. So condition is, if any relation is not symmetric, then definitely it will be anti-symmetric relation. That is, If we have given one relation like A comma B, then B comma A, and one more B comma C C. So it is not symmetric. It is not symmetric. That is why it must be anti-symmetric. Why it is not symmetric? Because for A, B, there is B, A also, but for B, C, B comma C, there is not its inverse relation, that is C, B is not given here. That is why it is not symmetric. That means it will be anti-symmetric relation. So next, transitive relation. What is called transitive relation? Transitive relation. What is called a transitive relation? So another relation, suppose, say if we have given A comma B, AB, BC, and A comma C also. Transitive. For any relation, if there exists A comma B and B comma C, that implies A comma C must present there unless it is not a transitive. So this type of relation we can say as a transitive relation. Then what is called universal relation? Universal relation, suppose we have given here A equal to A comma B comma C set. Then if we want to find out A cross A cross A, if we want to find, then A cross A will be universal relation under set A. U suffix A will indicate universal relation under the set A. So after multiplication A cross A, whatever relation will obtain, that will be the universal relation. And what is the transitive relation? Among that, transitive will be A comma B if there is two relation like A comma B and B comma C. So for that it will end with B and start with second one B. That is the second component and first component, whenever it is same, then A comma C must present in that relation. Then it will be transitive relation. Now, universal relation, transitive relation, then what is called equivalence relation. Equivalence is reflexive, symmetric, and transitive. Equivalence, it is reflexive, symmetric, as well as transitive. If it can satisfy all these three conditions, then it will be an equivalence relation. It will be an equivalence relation. If any relation can satisfy, first of all, it must be reflexive. Secondly, it should be symmetric as well as transitive also. Then only we can say that will be equivalence relation. So let us say what is called null relation. What is called empty or null relation. If r equal to 5, then it will be an empty or a relation or null relation. It will be empty relation, empty relation, or void, void relation. Empty or void relation if I equal to 5. So that is also a relation. Now there is some dissimilarity if one relation is given as say single order pair, suppose A comma B only. Only one order pair is given here, then definitely it will be transitive. Any single order relations are transitive. Any single order relations are transitive. Any single order relations are transitive. So we should remember it. Any single order relations are transitive because reason is there is no any other order pair to compare. There is no any, in case of a single order relations, there is no any other relations where we can compare this to satisfy the condition of transitivity. So that is any single order pair we can say as a transitive relations. For any equivalence relation, if one relation. First condition is it should be reflexive. Next one, it should be symmetric. Then last one will be it should be transitive also. Then only you can say it is an equivalence relation. So about the relation in the next class, further detail I'll explain. Thank you for